next concept which you are going to see is maxima and minima. So before going into mathematical part of it, we will first understand what is it. So f of x, let f of x be any function. So if I want to draw f of x in x axis with respect to x axis, so the curve could be of any type, right? The curve could go like this or come like this, or the curve could be like this, or curve could be like this, or it can be like this, anything. The curve has different natures. The curve can have different natures. So what does that maxima and minima implies? For example, for instance, the curve is, for instance, let us take the curve is varying like this. Okay. The curve is varying between these 2 points. So maxima means where does the curve reaching maximum f of x value, that is maximum. Let me say it again. If you see here, 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 out of these 3 points, which is the maximum f of x value, we know that this, right? This will be my maximum f of x value, f of, let us take it as 1, so f of x1. Corresponding to this, my x1 will be there, right? So this x1 is nothing but my maxima. That is the value of x at which my f of x will be maximum. It's a simple concept. So in the same way, what about minima? The value of x at which f of x is becoming minimum. So here, which one? Obviously these two are almost same, and if I draw a straight line, yeah. So if I take this as x2 and this is f of x2, so the value of f of x, when the value of f of x is becoming minimum, the corresponding value is x2. So maxima and minima, if they ask you maxima and minima, then you need to find x values. If they ask you maximum value and minimum value, then you need to find corresponding f of x value of your maximas. Simply maximum value or minimum value, then you need to find f of x. If they ask maxima or minima, it means x. That is the value, the x value corresponding to maximum f of x, maximum f of x will be my maxima, and x value corresponding to minimum f of x will be my minima. Okay. So now you could see here, it's very simple. You could see the curve is varying like this, and what about the slope at this point? What is the slope? Slope at all these points. Or if I draw a tangent to this, tangent to all these points, what does it represent? It represents the differentiation at this point, right? Or in the other sense, it represents the slope. So what about the slope? The slope is parallel to x-axis, which means it is 0. So at this point, slope is 0. If slope becomes 0, we know that slope is nothing but dy by dx. Just go back to the old videos and refer. I said it in one video that dy by dx represent the slope. So here dy by dx represent the slope. Here at all the points, all the points where the curve is getting changed, you could see, right? Here the curve is going up and now down, and up and now, and up and down. So where the curve changes its nature, here the curve is changing its nature. Here the curve is changing its nature. Here the curve is changing its nature. So where the curve changing its nature, there the slope value is becoming 0, which is nothing but differentiation value is becoming 0. So these points, the points at which the nature of curve or nature of f of x is getting changed. Here you could see going up and going down, and going down, going up, and going up and going down. So exactly at this point, the nature of f of x is getting changed, right? So these points are called as critical points. So now what you could relate from the maxima, minima and critical point? Maxima and minima should surely lie in any one of the critical point, right? So critical, but not all the critical points are maxima and minima. That has to be clear, because this value is not maxima and minima. This and this is going to be maxima and this is going to be minima. Only 2 points are maxima and minima. All other every point where the nature is changing is a critical point, but only where but we need to find maxima and minima such that the f of x is becoming maximum and f of x is becoming minimum. Okay, so what are the observation which we made? Maxima and minima surely lie in critical points, corresponding to critical point only, but not all critical points are maximas and minimas, and at critical points the slope is 0, so the differentiation will be 0, which is nothing but f dash of x. Dy by dx is what? F of x is y, so dy by dx is nothing but f dash of x. So f dash of x is 0 at critical points. And what else? Yeah, that's what we made from this observation. Now we go to mathematical details, how to find maxima and minima. So we will see how to find maxima and minima. So f of x is some function. So first step for determining maxima and minima is differentiate the function and equate it to 0. Why we need to differentiate and equate it to 0? Because exactly at critical point our curve is getting changes, our nature of the curve is getting changed, so obviously the slope will become 0 exactly at critical point, right? Exactly at critical point slopes will become 0, so I am equating it to 0 and I am finding critical points. So some value, let us take that x is equal to a and x is equal to b is a critical point which I determined from f dash of x. So first step is done. Equate f of x and find x value, and x value will be critical points. All are critical points. Now come. Now we need to check first derivative. Now we need to check, there is two possibility, right? Critical points may have maxima and critical points may have minima too. We know that f dash of x equal to 0 means there will be maxima and minima, but we don't know that whether it will be maxima or it will be minima. That is what we need to find, right? So what we need to do here, see, it is getting increased and it is getting decreased and it is getting increased. So you could see what is the value of slope here at this point, at this point, at this point and at this point. You can see it very easily, the slope is positive. Here slope is positive. If the slope is positive means f dash of x should be positive. Here slope is becoming 0. Here slope is negative, which means f dash of x is negative. Simple, that is what we need to find. You would have got a and b, right? X is equal to a. What you need to check, take one value before x is equal to a. If x is equal to 5, for example, if x is equal to 5, take one value before x is equal to 5 such that x is equal to 4, and take one value after x is equal to 5 which is equal to x is equal to 3 for an example. So if I substitute x is equal to 4 in my f dash of x value, that is if I find f dash of 4, if it is positive and x is equal to 6 here, and if f dash of 6 is negative, then we are sure that the point will be maximum. You could see here, because it is increasing, the slope is positive in left hand side and the slope is negative in right hand side, and if the slope changes from positive to negative, then in between positive slope and negative slope there will be maxima. Now come for this case, what is happening here? Here the slope is negative, here the slope is positive. So what you can observe here, if the slope changes from negative and it reaches 0, and then if the slope increases to positive, then it is minima, right? Because the value is minimum. So what I need to do in case of minima, same principle, take some x value, a critical point value, you will get it from this, x is equal to b. Choose one value before b and choose one value after b, and substitute that value in f dash of x, and if that f dash of x is negative, and then substitute this value in f dash of x, and if that f dash of x is positive, then the slope is getting changed from negative to positive. So so the point which we got is minima. Don't get more confusion, simply I will say, find a critical point and find f dash of x before that critical point. If suppose this is a, find f dash of x before a. and find f dash of x after A also. If f dash of x before A is positive and f dash of x after A is negative, then the curve is changing from positive to negative, so it is maxima. So A will be maxima. And take B. Take one value before B and take one value after B. Take one value before B and take one value after B, and substitute the value which you taken before B in f dash of A. Sorry, in f dash of x, f dash of B. Find f dash of that value. And if that value is negative, and substitute the value which you taken after B in f dash of x, and if that value is positive, then that's it. Your value will be minima. Simply, slope is changing from positive to negative, then you will get maxima. Slope changes from negative to positive, then you will get minima. For finding slope, you need to differentiate it. So just take one value before A and take one value after A, then substitute it, then you can determine it. So it is the first derivative test. For few problems, first derivative test will be useful, and for few problem, the next thing which you are going to see, that will be useful. You can use any one of that based on the problems. Now we will see the second derivative test. First step remains same. Find f dash of x equated to 0, and you will get critical points, x equal to A, B, C, whatever it is. So what you need to do here is differentiate x value, differentiate f of x again. That is, find f double dash of x, and whatever critical point you are getting, substitute in that. And if f double dash of A is greater than 0, then x is equal to A is minima. If f double dash of A is lesser than 0, then x is equal to A is maxima. This looks very simple, right, when you compare to the first derivative test, but it doesn't mean that it will be always simple. In few examples, first derivative test will be useful, and few problems, second derivative test will be useful. So in second derivative test, differentiate the f dash of x again and substitute the critical points. Here my critical points is A, and substitute the critical point, and if it is greater than 0, then x equal to A is minima, and if it is less than 0, then x equal to A is maxima. What if f dash of A is equal to 0? F double dash of A is equal to 0. What to do? We will see that now. So here we have the next case. F dash of A becomes, if suppose f double dash of A becomes 0, what we will do? Simple. Differentiate f dash of x again, that is, find f triple dash of x and substitute A and check whether it is becoming 0 or not. If f triple dash of x is also 0, if f triple dash of A is also 0, then find again differentiation, again differentiate it. Find f4 dash of x and substitute A. Then if f4 dash of x is also 0, then find f5 dash of x, and repeat this process continuously until you get a non-zero value. Okay, keep on differentiating it, and finally at one particular value, one particular times your differentiation, you will get non-zero, right? That is the step you need to do. So now, once after getting the non-zero value, let us assume that at nth differentiation, when I differentiate f of x nth time, I am getting a non-zero value. Now the step remains same. If n is even, which means when I was differentiating it second time or fourth time or sixth time or eighth time or 10th time, when I differentiate it in the even number of time, differentiate it at an even number of time, when n is even, then you need to follow this step. What is that step? Remains same. F power n A, if greater than 0, it will be minima. If f power n A is less than 0, it will be maximum. Nothing but x will be minima when f of A power n is greater than 0, and f of A power n is less than 0, then x will be maxima. If suppose n is odd, that is f triple dash of A, f5 dash of A, f7 dash of A, f9 dash of A, 11 dash of A, if n value is odd, that is I am differentiating f of x odd number of times, then there will be no maxima and no minima, right? So on that point that is x is equal to A point, where there is no maxima and minima, that point is called as point of inflection. Okay, so one point I need to clarify before going for the next. We will solve few problems in maxima and minima, and next concept which I am going to discuss is increasing and decreasing function. We will solve some good number of problems in this, but before going into problems and increasing and decreasing concept, I need to say about one thing. when I am equating f dash of x equal to something and I am finding some value and a, b, and these a, b value will be my minima or maxima, and once after finding whether it is minima or maxima, and after that if I substitute it in f of a and f of b, this will be my maximum value and minimum value. Okay, it is the difference. It is minima, maxima, minima I will get it, and maximum value and minimum value. And so don't get confused. If in the question they ask maxima and minima, then directly substitute x value, and if they ask maximum value and minimum value, you need to substitute x value in f of x and you need to find that, right? We will do few problems, in that you will get clear knowledge about it. And before going into the next concept, there is another important thing I need to say. When I was initially said there will be curves like this and all are critical points, right? So there is an important thing to be said. It is the maxima of all, and this is the minima of all, right? So if in the problem they ask you absolute maxima or absolute minima, then you need to find maximum of all the critical points. You will be getting some 5 or 6 critical points. Out of all this, which one will be maxima, you need to find it. Okay, we will do problem on that also. If it is an absolute maxima and minima, then you need to do this. If it is a local maxima or local minima, then there is no issues, you don't have to do that. We will do a problem on this absolute maxima, local maxima case also, maxima, minima, and maximum value, minimum value case also, and then increasing function, decreasing function. So next concept we are going to see is increasing function and decreasing function.